Hello, this is Mr. Wynn, and this video is solving radical equations and inequalities. So roots and powers are inverse operations, meaning they undo or cancel each other out. If you have a square power problem, then you need to square root both sides. So my first problem, x squared equals 100. A number squared is 100. Hope you know it's 10. But to show the work, to get that square power, I got to do a square root both sides. Square root of x squared, square root cancel out, it's just x. Square root of 100 is 10, plus or minus 10. You can do the tree branch. That's how you get 10. The opposite's true. If you have a square root problem, then you need to do the square power both sides. So here, the square root of some number is 8. Hope you know the square root of 64 is 8. The work to get the 64 is to do the square power on both sides. Square root, square power cancel out, just the inside x, and 8 squared is 64. So that's the work to get 64. This idea works for third powers, fourth powers, fifth powers, or any powers. So here, x to the third power is 64. I'm going to cube root both sides. To get rid of that third power, I get x equals 4. Here, the cube root of x is 27. I'm a third power both sides. And I'm going to get a really big number. Let's see. Alright, the calculator says that is 19683. So if you're ever curious, check what's the cube root of 19683. That will be 27. So again, this works for any power, even their fractions, and any index, even if they're fractions. The key is to do the correct operation. You should not be doing a root of a root problem or a power of a power problem. Since you want to cancel out the roots or the powers, you have to do the opposite. So you should have one of each. Alright, so to solve equations with radicals, you're going to follow these 4 steps. You'll isolate the radical to one side of the equation, which means you move things away. You're going to raise each side of the equation to the correct power. That power will always match the index. So going back to here, if I had a third root, I need a third power. If I had a square root, I need a square power, because the index was 2 and 3. Once you do that, you're going to solve what you get, like normal. Usually there's going to be foiling and stuff. Then lastly, you have to check your answers for extraneous solutions. You plug into the original equation, make sure both sides match. If it doesn't, we cross the answer out. Those answers will pop up, because we're squaring and it's supposed to be quadratic. So for the first problem, the square root of x plus 2 plus 4 equals 7. I need to get the square root thing right here by itself. To get that by itself, I need to move that 4. To move the 4, I'm going to subtract it. So I get square root of x plus 2 equals 3. Now that the root sign, the radical is by itself, I'm going to use the correct power. To go to square root, I do a square power, both sides. Alright, so square root, square power cancels out, just x plus 2. 3 squared is 9. I'm going to solve this like normal. I can subtract 2 both sides. I get x equals 7. Now before I box it in, I need to check. So I'm going to plug into the original problem. Here's the check. Square root, I'm putting 7 for x. 7 plus 2 plus 4 is supposed to equal 7. I work on the inside. 7 plus 2 is 9. Plus 4, again, supposed to equal 7. Square 9, you should know it's 3. Plus 4 is supposed to equal 7. And those combined get 7 equals 7. That's true, that's a match. So my answer is x equals 7. Alright, next problem similar, a bit harder. Solve this. Now there's 2 square roots here. So you want to get the more complicated one by itself. Thankfully it started as a complicated one equals the other one. So square root of this thing equals 2 minus that square root. I'm going to square both sides. You do this once you have a single radical by itself. And square root, square power cancel out, so this is x minus 12. But over here, I'm not allowed to distribute that exponent 2 because that's multiple terms. You have to FOIL, you have to write it twice. So I'll write it like this. But to expand it, now we're going to FOIL it. And FOIL is first, outside, inside, last. So this left side stays the same for now. 2 times 2 is 4. 2 times negative square root x is negative 2 square root x. Negative square root x times 2 is negative 2 square root x. Negative square root x times negative square root is positive square root x squared, but square root of x squared is x. Remember, when you do a square root times itself, it's just the inside. We can combine like terms. So this is 4, negative 2 root x minus root x is negative 4 root x plus x. Now we get this next root by itself. So I'm going to move this 4 by subtracting it. Also move this x by subtracting it. So this cancels, this cancels. This is just negative 4 root x. over here, luckily, this x and x cross out. If it didn't, we'd have a much harder problem. That's negative 16. The square root's almost by itself. I need to get rid of that negative 4 by dividing negative 4. So I get positive 4 equals square root x. Now to get rid of that square root sign, since it's by itself, I'm going to square both sides again. You're allowed to square both sides multiple times if you need to. So I get 16 equals x. Before I box that in, I have to check. So I'll do it right here. So here's the check. Plug it in. So square root 16 minus 12 is supposed to equal 2 minus square root of 16. Well, this inside is going to be square root of 4. And this is 2 minus square root of 16. Now square root them. Square root of 4 is 2. Equals 2. Square root of 16 is 4, so minus 4. That gives me 2 equals negative 2. That's false. So this answer fails. So there's no other answers. This one's no solution. Alright, so you must check your answers. Alright, 2 more complicated ones. Here's another problem. 2 times that thing to the 1/3 power minus 4 equals 0. Now remember that 1/3 power is just a radical. So I can change it to make it look like this. I can say this is 2 cube root 6x minus 3 minus 4 is equals 0. So you want to get the radical by itself. So I move this 4 over first by adding it. So 2 cube roots of 6x minus 3 equals 4. I need to get rid of that 2 in front by dividing by it, because that's a multiplier, has nothing to do with the radical. So I get cube roots of 6x minus 3 equals 2. Now the radical is by itself, I'm going to use the correct exponent. Power matches the index. Since this is a third root, I'm going to do a third power, both sides. Third root, third power cancels out, it's just 6x minus 3. Then 2 to the third power, 2 times 2 times 2, that's 8. Now you do basic algebra. Add 3 both sides. 6x equals 11. Then divide by 6. I get x equals 11 over 6. Now you still check this answer. I'm going to save time, and I'll say the check does work. So check does work. Because it's true. Alright, just save time. Now, I want to do that because I want to show you this other thing. Although that work we did is correct, there's another way of doing this. You don't have to change it to a radical. You can do the exact same thing. So, if I leave it like it is, you could just try to get that thing with the exponent by itself. So, I add 4 like normal. Then I'm going to divide by 2, just like before. 6x minus 3 to the 1/3 equals 2. Notice this step in green, where I'm at now, is pretty much this step over here in blue. They're the same thing, but one has the exponent form, one has the radical form. Alright, but the next step is actually the same thing, because if you know your exponent rules, to get rid of a fraction exponent, we can actually just raise both sides to the correct power. We're trying to figure out what do I multiply this exponent by to make it 1. So you're going to raise both sides to the third power. Because 1/3 times 3 is 3 over 3, which is 1. So that would make, when the exponent's 1, really the exponent doesn't care anymore. It's just 6x minus 3. It is still 2 to the third power. That's 8. You're still going to add 3. Then divide by 6, get the same answer. So you are allowed to use whatever formula you like more. You can make it a radical and then use the correct power, or you can leave it as a fraction exponent and then raise the correct power. So just giving you multiple options. Can you still check, which it does work out. All right, 2 more. Here's another one. Get it by itself. I'm going to add 6 both sides. So 3/4 root of 2n plus 6 equals 6. Get rid of that 3 in front by division. So 4th root of 2n plus 6 is equal to 2. To get rid of the 4th root, you need to use a 4th power. 4th root, 4th power cancels out. This is 2n plus 6. 2 to the 4th power. 2 times 2 is 4. Times 2 more is 8. Times 2 more is 16. Then you're going to subtract. 2n equals 10. Then you're going to divide. N equals 5. You need to check. Check will be true. So that is the answer. We're good. Just save time. All right, last type. Inequalities. So y'all know inequalities means there's graphing and shading. If there's an inequality with a radical, there's a next check you have to do. So look at the index. If the index is odd, so it's like 3, 5, 7, solve like normal, no extra steps. But the index is even. For example, it might be a square root of a number, or the 4th root of a number, or the 6th root of a number. Those are even indexes. You have to find the domain restrictions by setting the inside of each even radical, index radical, greater than or equal to 0. Remember, we can't do the even root of a negative because that's going to be imaginary. We have I. In addition, the answer will be the overlap of the answer and all the domain restrictions. So usually we'll have an and inequality. Now remember, there should be shading. If you're unsure, you can always do a test one for each section to see if that should be shaded or not. So let's do this problem. I'm going to solve this. This is a square root problem. We're going to have a side problem because the index is 2. It's even. So because I'm doing a square root, I don't want to square root a negative number because that's I. So my side problem will be this 5x minus 10 has to be greater than or equal to 0. Because if it's negative, that means there's I involved. So you solve this pretty easily. Basic algebra, plus 10 plus 10. 5x greater than or equal to 10. Divide by 5. You get x greater than or equal to 2. That's going to be part of my answer. There's no more radicals, so I don't have any more side problems. Now I do the main problem. So main problem, just like earlier, we're going to get the radical by itself. Subtract 3 both sides. So positive square root of 5x minus 10 is less than or equal to 5. The radical is by itself. You can go to the radical by doing the correct power of both sides. So I'm going to square both sides. So this will be 5x minus 10 less than or equal to 25. Basic algebra, get x by itself, add 10. 5x less than or equal to 35. And then divide by 5. I get x less than or equal to 7. Alright, so when I graph this, it has to be a combination and the overlap. So we have 2, we have 7. For 2, it is closed and going right. For 7, it is closed and going left. So it's meeting at the middle. So my overlap, if you're going to tell, will be between these two. If it's between, that is and. You're supposed to say x in the middle. Less than signs, always. Smaller number, left number on the left. Bigger number on the right. It's closed, equal sign. Here's my answer. If you're unsure, you can try a test point between 2 and 7, say 5 or 3. See if it's true or false. It's true. You try a test point on the left of 2, for example, 0 or -1 or 1, and it'd fail, it'd be false. You try a test point to the right of 7, for example, 10, and it'd fail, so that'd be false. That should be it. Thanks for watching. See you in class. Make sure you ask any questions then. Bye.